Hi, this video we're gonna look at example of using decompose method um, to find the 2D resultant force. So you are familiar with this problem because we solved this problem finding out the 2D resultant force already using a triangular rule, and in that method we have using the law of sine, cosine, parallelogram geometry to figure out the both magnitude and direction. And now we're solving the same problem, however we're using this decompose method. Like I said in the previous video, decompose method is actually most common universal used one in statics. That's what we're going for. Okay, so two forces, and first step to solve that is we're going to decompose. Step 1. Decompose each force, P and Q, to X direction and Y direction. So make a note, this is each force. Okay, so if I were to look at P, I copy out P, and it's 40 Newton. And we do know the angle here is 20 degrees. So if we were to decompose that, we're going to using the rectangle. So I basically create rectangle here. You said you didn't. You can add a dash line. Basically, that's a rectangular component. And this will be our P at X direction component. And this is going to be our P at Y component. And we're solving those. So pause for a moment, thinking about how you find it. In the previous video, we're talking about to find a px. The rule of thumb, if this angle is 20 here, if it is adjacent, we're going to use p, this hypotenuse here, times what? If it's adjacent, cosine, right? If this angle is opposite, then we're going to use sine. That's a rule of thumb. So this px here, look at this angle 20 degrees. Is that adjacent or it's opposite? It's adjacent. So in that case, if adjacent, we're going to use p times cosine the degree, 20 degrees. And for this force y, and this angle is 20, and we know that angle is 20. And so y is going to be 40 times sine 20 degrees, because it's opposite to that angle. So go ahead and solve in that. So we're going to find the px is going to be this 40, this force you are decomposing, 40 times cosine 20. And let's see what we got. Put in the calculator, 40 times cosine 20 degrees, and we will have 35.59 Newton. That's X component of this force. And how about Py? Py here, we said it's 40 times sine 20. So that's the difference. And then that will give us 13.68 Newton. Now you find the X component of Y, each of them. Then we're going to look at another force because there's Q. So do the same thing for the Q. Q is 60 Newton. And we're going to decompose using rectangular component, and we're going to get those two. We can go ahead and draw the dash line if you want to, and that's going to be your X component. This is your Q, so here's going to be QX, and here will be our QY. Now we need the angle. So how do we label that angle here? So this is your Q, and this is basically your X direction, right? So from x-axis to this angle Q, to this force Q here, and what is the angle here? That's right, 20 plus 25. So that's going to be 45 degrees. That's how that's coming about. So in that situation, so Qx is going to be the 60 Newton times, you tell me cosine or sine? That's right, cosine. Why? Because this is angle is, well, this is adjacent, cosine 45 degrees. And now Qy is going to be this hypotenuse 60 times this angle This angle is 45 degree, and this QY is opposite to that angle, so we'll have sine 45 degree. Okay, so let's go ahead and put in a calculator. 60 times cosine 45. That gives me this value as 42.43 Newton. And 60 times sine 45 is going to be exactly the same as cosine 45, right? So 42.43, you can verify it. Then we have this, we finished the first step. Our goal for the first step is just decompose each force to x and a y. We did it. And now the second step, thinking about our logic. In the last video, we said once we decompose, we're going to add all the x together. That gives us summation of all the forces at the x direction. And also we're going to add all the y together. That's going to give summation of forces at y. In here, be aware, we're going to make sure we're going to consider signs. Which means if it is the force is like to the right, then it's positive because it's on positive x-axis. However, if it's going to the left, you make sure it's going to be minus. It does not apply for this problem, but it will apply in the other problems you solve. So consider signs here. It's very important. Now let's take a look. So if we were trying to add all the x direction, so we have x direction right here, and this is x direction, those two. Because the remaining one, I'm going to highlight in green. This is your y, and this is our y. Right? So we're going to add our x together, and both of them are going to be positive because both of them is pulling to the right. Okay? So we did consider the sign here. Plus 35.59, and let's quick calculating that. It's going to be that value, right? 78.02 Newton. And then we're going to do the same thing to adding those green, which is your y-axis. Add them together. First one is 13.68. It's positive. Why? Because it's going upward. And then add this 42.43. Why it's positive? Because it's also going upward. Because that y component is going up. So it's positive. So when you add them together for this, we got this value, right? Okay, so that's our sum x and sum y. We completed our step 2. Now the last step is we are going to combine now, right? Earlier in the first step, we decompose. And then second one, we add them together, x and y respectively. And then now, remember what we did in the previous video? This is going to be sum of fx. This is going to be sum of fy. And you want to find out what's going to be the resultant. It's going to be here. That's going to be your r. And how do we calculate r? R is using this formula. And how do you find the angle? This angle is counterclockwise from x-axis. That angle is going to be inverse tangent of y, because this is your y. This is over fx. So that's how we calculate the direction. Now let's go ahead using the value here. So it's inverse tangent. Fy is 56.11 and fx is 78.02. So go ahead and plug into your calculator, which I'm doing now. And then we're going to take a inverse tangent. and I have the answer as 35.72 degree. Okay, so we got our answer. What's our answer for this resultant, 2D resultant of this P and Q applied at this bolt A? Resultant is this. Oh, we didn't put a calculate resultant. Sorry, let's go back to solve that. So going back to this pathogram, so I will have 78.02 square. I'm kind of running out of space, so I'm going to move on here. So this R is going to be square root 78.02 square plus 56.11 square. And let's see what we got in the calculator. Plus 56.11 square. And then we'll take a square root of that. And I have 96.1 Newton. Now we got our magnitude. We also get our direction. 96 and 35.7 degree. Then I'm curious if this method, which this is new method called decompose to x and y, see if we get the same answer as what we did in the triangular rule. Okay, 96 Newton and 35. So let's go back. I think I have over here. So we have 97.73 and it's 35 degree. Okay, so slight different, but it's very similar. But you kind of know probably where the potential tolerance coming from, right? Because when you do fx like qx, let me see. There'll be potential some tolerance. So I realized there's some kind of tolerance, and I actually paused for a second and I went back to check my numbers. You probably along the way already figure out the mistake I already did is right here, right? Is this number is wrong. That caused the trouble. 40 times cosine 20 is going to be a different value. It's 37.59 Newton. Well, so knowing that, assume everything is right, and I'm going to go ahead and change this x, this value right here. So that will be 37.59. So knowing this, this answer will not be correct. So that will be 80.02 Newton. So knowing that, which number will be fixed? It's a domino effect. So this, it's wrong. It's going to be 80.02. And this will be wrong also, 80.02. And this is a humbling experience for me because you see, I make mistake. So in this situation, we just need to know troubleshoot. We got a slight different answer. It doesn't look like it's tolerance. So go back. Yes, there's a mistake. So let's recalculate this one. So we'll have 80.02 plus 80.02 square plus 56.11 square, and we'll take a square root of that, and I will get 97.73. Woohoo! Because that's exactly the same answer we had over here. Yes, using the triangular rule. Now we're convinced, right? Okay. So knowing that, and I'm going to come back to find this direction, the angle theta. So it's inverse Fy over Fx, inverse tangent, 56.11 over 80.02, and then we take a inverse tangent for that. Then the answer will be 35.03 degree approximately, and we can go back to look at that. 35.04, very similar. Okay, so that is going to be for the decompose to x and y, the first example we just did. Okay, I'll see you on next one. Bye.